everyone, welcome to the Dapr 116 release celebration event. And I'm Mark Duiker, Dapr community manager and working at Digwit as a developer advocate. And with me is Mark Vossel, CEO of Digwit and also one of the co-creators of Dapr. Welcome, Mark.
Welcome. It's fantastic to be here today. I'm excited to talk about all the things we've done in 116 and to show off all the great work we've done inside the Dapr project.
Exactly, yeah, and yeah, we have quite a busy agenda because we have like just 1 hour, a bit more than 1 hour of content. But we have a lot of speakers and doing a lot of demos of a lot of the 116 features. You want to give some highlights what we're going to talk about?
Yeah, we're going to cover a lot of things inside workflow and the great improvements we've done there. We're going to look at things across some of the SDKs, including Java, and how we brought that together with Spring Boot developers. There's work we've done inside Dapr Agent in the Python SDK. And then one of my favorites is how we've done Federated Identity. They're all great pieces of the 116 work we've done, and there's probably much more into it, but these are some of the highlights.
Nice. All right. I think we should then immediately start and have Yaron join us to tell his own story about 116. All right. So late in the year, on November 5th, we are organizing Dapr Day. It's like a virtual conference all about Dapr. So you can still submit your sessions until the end of this month, end of September. But you can also, of course, already register. It's like a completely free event. So yeah, we welcome lots of sessions there about how you're using Dapr in production, but also how are you doing like a local development with Dapr, how you're using like Dapr workflow and AI agents. So yeah, please submit your sessions for Dapr Day.
All right, with that, let's bring Yaron in and talk about some of the great work. So Yaron, kind of give us the highlights. What are the things that you loved about 116?
Well, first of all, the fact we were able to get it out fairly, without too much pain involved in the release process. That was a great release, both for users and our maintainers, I believe. And for me, basically, the highlight is the improvements we've done around workflows, which we're talking a lot about just because of the traction it's receiving from our community. And those improvements essentially come in the form of performance, which is critical to any workflow application. And so if you just upgrade from 115 to 116, you'll be getting improved throughput, reduced latency. A few errors you might have been seeing before are gone now, based on just stability work that we've done in the underlying runtime, which is our scheduler service, and how it connects to the database. And just all up, workflows should be made just a whole lot more reliable. And there's going to be additional tooling that's actually coming into the Dapr CLI. So if you're using Dapr CLI, please be on the lookout for that for the next 2 or 3 weeks. There's going to be great commands coming out to allow you to list all the workflows and the activities and really see some of the stuff that's happening in your cluster as workflows are actually executing. Other stuff we put in there in the 116 release is related to connectivity. So we now have the ability to have Dapr talk to things like MCP servers, because Dapr external service invocation now supports HTTP streaming, which means if you have an MCP server that you're communicating with, now you can put Dapr in front of it, and suddenly you get authentication workflows that you can kick off before talking to the MCP server, essentially authenticating your client. You get retries, circuit breakers, resiliency policies, and of course, tracing and telemetry that Dapr provides in the MITs, all out of the box when you're just invoking an MCP server via HTTP streaming or just regular JSON RPC. So that's definitely functionality that you need to be on the lookout. Now, of course, it doesn't only support MCP servers. Any form of backend that does HTTP streaming should be supported with this out of the gate. So really important to look at. Other stuff we've put in the release is also related to workflows called remote execution or multi-app workflows. This is how we call it. And multi-app workflows really allow you to separate out applications that run activities from the application that hosts the main workflow. And what this allows you to do is, for example, if you're running Dapr on Kubernetes and you have certain nodes that are better off with certain tasks, then you can have your workflow to be spun up on a node that is fairly low on CPU and memory that just needs to orchestrate the workflow. But then, for example, if you have an LLM that needs to talk to a model running on a GPU instance, you can put the workflow activity on that specific node, and that'll actually kick off the workflow activity that talks to the LLM. And so you can have special provisioned infrastructure that's fit for purpose for certain activities while the workflow itself is distributed. So this is a feature that I'm very proud of, because it just opens the door to a whole lot more use cases. We've also enabled, as Mark alluded to earlier, federated identity. So being able to extend authentication to external components using SPIFFE and OIDC. Take a look at that. This is great, and we're talking about that today as well. All up, we've improved quick starts. We've got new quick starts in place for agentic workflows as well. Documentation's been improved, and just go check it out, play around with it. If you have any feedback, please come on Discord or open issue on GitHub.
Yeah, fantastic. So much in there. We can only just about squeeze the best into 1 hour, but we'll get through it all. And we really needed 5 hours to cover all of this.
Yeah, exactly. Yeah. We'll also spend like many other like Dapr events and webinars with all these new features.
Yeah, we'll have actually most community calls, even a community call next week, which we'll be doing some more stuff on. Yes. Yeah. All right. Thanks, Yaron.
Thanks, Yaron.
Thank you.
Yeah. And then, by the way, if you're watching now in this webinar, there is some means for you to actually engage with us. So there is a chat if you just want to say hi. There's also like a Q&A functionality. So if you have a question about one of the sessions, please make sure you write your question there, and then one of the moderators will look at the question. If you can't answer it now in the session, we'll get back to you later about this. I also have actually 2 polls during this webinar. Let me do the first one, which is about how familiar are you with Dapr, because we're always very curious. Are you like a Dapr pro running it in production for years, or are you here just because you're curious about Dapr? So let's do this first, and then we get to the next section. All right, so now you should see like in the interaction tab, which asks about how familiar are you with Dapr. So are you either like completely new? It's your first time that you're hearing from it. I guess not, but or did you hear from it but never used it? Have you used Dapr in the past but not at the moment? Or are you running Dapr in production? Yeah, so no one so far indeed is saying they're completely new to Dapr, which I did expect, because why would you sign up for this 116 webinar? So. And hi, Isabella. Nice you to join and say hi. Okay, just a couple of more seconds, but yeah, there are quite some folks are running Dapr in production, so that's actually great, great to see. Perfect, nice.
Yeah, it's pretty amazing to see.
Definitely was glad to see.
In production.
Yeah. All right, I think we should move on to the next section.
All right, so let's dive into Catalyst a little bit. A great way to build Dapr applications is to take advantage of Catalyst, and you can sign up to our Catalyst cloud service. Think of it as a way that you can build workflow applications, do service discovery, pub sub, take advantage of all the Dapr APIs, and of course, as Yaron talked about, build Dapr agents and deploy them there. And we're going to do a little bit of demo of this, Mark. So
yes, exactly.
Just dive in and show this off, because we're going to use this in some of our demos today.
Yeah. So I have this code here because I want to focus a bit on the local development experience, because typically if you develop Dapr applications, you have like Dapr installed locally, but if you use Catalyst, you actually don't need to have Dapr running locally. Of course, you can still have that, but it's not a requirement. So what I will do is I'll do like a pub-sub demo with 2 applications, a sender service and a receiver service. And normally each service has like a Dapr sidecar next to it. And of course, you're communicating via a message broker with a topic. But in this case, this entire middle section, so both the Dapr processes and the message broker, is all hosted by Catalyst. So you're not dependent on any local resources as you're actually used to with Dapr. So what I'm going to do now is I'm going to use Direct Catalyst to actually run these services locally. So I have like 2 .NET servers here, the sender and the receiver. And also pointing to a resources path that contains some resources like the pub-sub. In this case, Redis when you run it locally. And I also have like a declarative subscription. Now, I will first log into Catalyst first.
And this is just a pretty straightforward Dapr YAML multi-app run application you got here.
Yes, exactly. Yeah, indeed. Yeah, and maybe some people are not familiar with Dapr multi-app run, but indeed, this file actually contains a description of the different applications that you will be running, and also includes the pointer to where your resources are located. So what I can do now is I'm logged into Catalyst with the CLI, and now I can use the Catalyst CLI to actually spin up my applications, and then it will communicate with the backend to actually configure the PubSub message broker and to configure the application IDs in Catalyst. So I'm doing Digrid dev run and then point it to the Dapr YAML file. So yes, I wanted to create those resources in Catalyst. And there are different ways to create these resources, but yeah, if you already have like a dapr.yaml file, this is a very useful thing to do. So in the Catalyst backend, these resources are now being created, and also my applications are starting up here. So let me quickly switch back to the browser and show you Catalyst. So we now have two application IDs for my two Dapr apps that I'm just running locally. But you can also see here that Digrid also offers some services. So Digrid Catalyst has like a built-in PubSub message broker and a built-in key value store. So you don't need to have these running locally in containers.
So it's just like your dev experience, but hosted in the cloud for you.
Exactly. Yeah, indeed. Yeah, and in this case here we're also using a PubSub component, which Catalyst created for me because that I had configured in my resources path. And there's also already a PubSub subscription created because that was also a declarative file that Catalyst picked up and now created in this hosted environment.
And the amazing thing about Catalyst, of course, is that you can run your app anywhere. Yes, you can run it on your local machine, on a VM, on a container app.
Yeah, you're not limited to
function runtime is everything.
Yeah, exactly. And what you can see here in the logs, both my applications have started, but also there's now a connection from my local environment to the Catalyst backend. So it says now we have connected both of the app IDs. So now I can actually make a request to my sender application, which has like an HTTP endpoint. And this sender application will then post messages through Digrid to the receiver. So let's do that. So here we see the response, and here we can see in the logs that communication has actually worked. So I can make a couple of more requests. So this is now all going through through Catalyst. And when you look back in the Catalyst backend, let's briefly go back here. We can actually look at the call graph because here we can actually see both our applications. We can see a sender, it's sending it to the Digrid hosted message broker, and then the receiver is receiving these things.
And you see all those great metrics as well, don't you? In terms
of it's not there yet, but yeah, soon this will be updated with the actual error rate and latency and things like that. Yeah. So yeah, it's a very fast way to get up and running, especially because you don't need to install many things locally.
Yeah, and you can run your application wherever you want. Great stuff.
Right. Yeah, so if you want to try it out, go to digrid.io/catalyst. You can then sign up for the free cloud hosted version. And very soon there will also be an option to host it privately as well. So this is really meant for enterprises that you can host in your own cloud.
Yeah, we have options so you can host Catalyst yourself and run it inside your own infrastructure. And that's Catalyst Private. So reach out to us if you want to find out more of that. Okay, with that, let's dive into 116 and let's bring Josh on. And Josh will kind of cover all the great stuff we've been doing inside Workflow and inside Actors.
Yeah, hello. Sharing. Hey, Josh, and then you can start sharing. All right.
Sure. Let me see. Share your screen. Alrighty. You see my screen?
Yep.
Good stuff. All right. Well, hello, everyone. I'm Josh. I'm a maintainer of the Dapr project. Yeah, I appreciate we've got a little bit of time today, so I'm going to go through a bit quickly. But I'm going to talk about some of the workflow and actor improvements we made in the 116 release, particularly around performance and resource usage. So yeah, if you're not sure about workflows, so workflows is a engine in Dapr which allows you to define kind of deterministic and durable execution of business logic that can take different paths based on inputs and outputs, and ensures that workflow durably executes until the end, or errors or whatever else. But yeah, if your kind of machine blows up from a meteor or something like this, then that workload will be scheduled on another node somewhere in your cluster, and then continue executing. So yeah, that's what a flow engine does. Again, to go through very quickly, obviously we're in Dapr, so you define your workflow in the programming language of your choice. But of course, now with multi-application workflows, you can now do it in multiple languages and do it that way as well. We support things like fan out, fan in, external events, timers, child workflows, things like this. But going on to, so now I want to talk about an important note about how workflow is implemented in Dapr. So in Dapr, we have the concept of actors, which is a building block inside of Dapr. And actors are a programming paradigm where you can define a single-threaded execution of a particular process, and you can have lots of them, and they can talk to each other. Yeah, you can kind of read more in the documentation about the actor model. But it's important to note that the workflow engine is built atop of the actor model, and this is done for a number of reasons. So in the actor runtime, we have the concept of this turn-based single execution of an actor. So a particular actor ID can only be executed once at a time in a particular place. And that is very useful in the context of the workflow engine, because when you have a activity that you want to run, you want to ensure that that activity is only run on a particular host at a particular time and not multiple places. Of course, you're going to be using a workflow engine for critical systems such as payment processing and things like this, and you definitely don't want to be paid twice or send money twice, things like this. So the actor model is useful for this. Also, it's useful for workload balancing. The concept in Dapr of actor placement. So we use the placement service to distribute actor IDs over a natural distribution across all of the replicas. And so with using the workflow engine on top of actors, we get a natural distribution of the workflow execution across all the replicas for a particular workflow. And then finally, identity-based isolation. So workflows have identity, they have a name associated with them, as well as an instance ID and an execution ID, and each of the activities are named and have these IDs, and these all get fed into the actor system, where we have an actor ID that represents all of these instance IDs and so on. And it's important to kind of bring this up, as a lot of the performance improvements that we made to the workflow engine also kind of tie into the actor subsystem as well. Great, so we made workflows stable, and that was great. But in this release, we focused a lot on the performance improvement. So I'm going to go a little bit into the kind of nitty-gritty details here, which might be interesting for you. And obviously, Dapr, the runtime is written in Go, so these are kind of a lot of these are kind of Go-specific things, but kind of generally kind of software engineering kind of stuff as well. So there's a lot of things we made changes to was reducing memory allocation, so reusing data structures across and reusing those data structures across different actors. In Go, we have this kind of nice utility called sync.pool, which allows you to, once you're finished with a data structure that you don't need to use anymore, you can give it to this kind of pool of data structures of same or different types, and that you can pull from that pool at a later time without having to go back to the operating system and say, give me more memory. We can reuse that memory. So we reduce allocations, we re-architected a lot of the actor runtime to reduce those allocations generally. So moving a lot of the shared memory kind of further up into the system, which reduced things a lot. We reduced contentions. So specifically, when I talk about contentions, that is where it goes back to the kind of turn-based actor kind of behavior I was talking about before, whereby instead of getting to a particular stop in the code and then having to wait to get to your turn, we've re-architected things so it reduces all of those contentions. So removing things like mutexes in favor of just kind of continuing on, and then also having a concept of this kind of optimistic getting of memory. So instead of having mutexes around maps and things like this, we use called a sync.map, which optimistically tries to write or read from that map, and then if it didn't win, then backing off, as it were. So kind of reduces the amount of time that the program will be kind of locked and waiting, which is useful to kind of keep things going, and also reducing context switching and things like this, which can lead to performance degradation. We reduced a lot of the Go routines that are used as well throughout the runtime in favor of using callbacks. This is helpful as well, because this means that although Go has a very great system with Go routines, and the kind of orchestrator for the Go routine runtime inside of Go is very good. Once you get up to something like 1 million Go routines at the same time, the performance degradation kind of isn't worth the benefit, right? Like, it doesn't really make sense to have any Go routines. So we've removed a lot of those as well, and we've also made some changes to the way that the Dapr talks to the scheduler service. We have more streams open now, which helps with bursting and kind of general throughput and things like this. So a lot of kind of smaller kind of nitty-gritty details, but once you kind of start adding them all together, you see this kind of a much better performance numbers generally, but also a better performance profile, which I'll move on to now. So, for example, this is running, these two slides are running for on an EKS cluster. So we're running a 3-node EKS cluster with T2 medium-sized nodes, I believe, and they will be running 3 replicas, and we're executing 1,000 workflows with I believe it was 15 activities that are kind of doing no kind of operations. The main thing is running workflows with those activities, and then we're scheduling all at the same time and then waiting for them to finish. The top one is 115 and the bottom one is 116. And you can see here with the memory difference, you can see that the 116 has by definition uses less memory. You can see it peaks at the top here at 130 across the 3 replicas, and at the bottom one they all peak at 90. What's also important to note is that they peak at the same place, which means that we have a much better memory distribution across our replicas. So we're using close to the amount of same memory, which is a good performance profile to have. This helps with replica bucketing. Also, they are a lot more stable. And this is much better for designing how much memory you're going to need. So capacity planning is much better when you have a kind of stable profile like this. So we have a much more memory profile stable system, and it is a lot more consistent across the replicas. So we're doing much better at utilizing all of the kind of resources across the replicas in the same amount of way. And we go on to CPU, and it's much the same story here. We're using less CPU by default. You can see here it kind of peaks out at 0.08, and before it was 0.25, so we're doing a lot better here. And again, it's consistent and they're much closer together, which is much better for kind of bucketing and capacity planning scenario. And then finally, there's a big graph here showing different scenarios. Less is better, and you can see blue is across the board lower. And as you can imagine, as we're going to get further up in scale with the number of workflows running at the same time or replicas, you can see the bigger difference in the performance improvements we've made. You can see here that some of the orange bars aren't even present on this graph because the system just conked out and can handle it and crashed out. So now we're doing a lot better now with stability with these kind of larger kind of workflow throughput scenarios, which is great. Also, a big takeaway, the main takeaway is we got less resource consumption across the board. That resource consumption is much more stable, particularly at scale, and we've reduced the workflow time to completion. So specifically going back to this graph, this is time to completion of the workflows. And I've got some links there as well. You can look at the release notes that we had for 116, which goes into this with more detail. And yeah, the workflow overview documentation I've added there as well to give yourself a bit of a read on workflows generally. With that, I will hand it back.
Thanks a lot, Josh. Great to see all these detailed diagrams. Cool. All right. I will quickly share my screen and to announce the next session, and that will be Cassie, and she's gonna talk about multi-app workflow and actually combining different languages in one workflow. So that sounds very exciting. Let me add you to the screen. Here you go. Welcome, Cassie.
Hello. Let me
share. Yeah, I will stop so you can share. Yeah.
Okay. Should see my screen now. I definitely see it. So, okay, yes, I am Cassie Coyle, and we will be going over the multi-app workflows. Specifically, be showing a Java and Go scenario. And I'm a Dapr maintainer and on the open source team here at Diagrid. So just to make sure we're all on the same page here, multi-app workflows is simply just workflows that span multiple services, potentially written, in different languages. So in this image here, we have 2 applications. App 1 hosts and runs the workflow, starts, it calls and runs the activity over here on app 2. And app 2, you can see here, just simply hosts activity A. It'll execute on app 2, and then we'll come back to app 1, and the workflow will end. So this is kind of like a very, very simple illustration of what that could look like, calling activities on other applications. You can also call, child workflows on other applications. This is just an activity call, just because I will be showing that in the demo. Here are some use cases where you can model end-to-end processes, obviously across applications. You are not limited to modeling your workflow just within the one app anymore. You can span the whole business like process across all your applications. And this really enables like decoupling ownership across teams and services. And obviously, they can write their application in whatever programming language, and it plugs into the bigger workflow. And then with that, you can also place your workloads where they run best, whether it's like GPU instances, geolocations, or different trust zones. And then with that, you can scale and evolve your workflows modularly. And today, we do have this supported in the Go SDK, and then calling activities is supported in Java. And then obviously more SDKs will come, and then calling child workflows will come in Java as well. So what we're going to look at today is an e-commerce order processing architecture where there are 4 different services. One is the Go orchestrator. It's an order orchestrator. It has 2 local activities, and then we have 3 different Java services that each have their own activity. This is the high-level architecture of what's running and showing y'all, and we'll look at some of the code too. I won't dive into all the specifics because it's a few different services, but at a high level, you can see I have the main workflow written in Go, and then I have 3 different services. You can see Java here. So the main order orchestrator workflow, the application's written Go. It will start the workflow. It will validate the order, which is just a local activity. It'll then call the payment service activity. That'll run inside this application here. When it's done, then we will call the inventory service, which will then be routed and ran on application 3, which is our inventory service, and that will reserve the inventory. And then from there, we're going to call an activity on app 4, which is our AI service. And we're going to generate recommendations on this application. When all of those like multi-application activities run, we're then going to complete our order, which is a local activity in our originating Go application, and that is our complete workflow. Now, let's look at some of the code for this. So this is inside our quick start repository. You can see this is like that same architecture we just looked at. Again, it's one Go orchestrator service, and then we have 3 Java services. I have all the commands how to run it with a make file, but I will show the Dapr run like multi-app configuration. So like the Dapr run, where we're going to give it this configuration where you can see here we have our app ID order orchestrator, which is inside our Go directory. If I come over to the directory structure and the file structure on the left, you can see inside the multi-app directory, we have a Go folder and Java, and then the respective like service code inside. So we have our order orchestrator. In Java, we have the AI recommendation service, inventory service, and payment service, and then the respective code there. So high level, this is our Go orchestrator. This is going to call and run our payment Java service. This is going to call and run our inventory service, and then the AI service. So I quickly want to note, I am going to call to start the workflow with my make test here. That is simply going to send a post request to start my workflow. Now let's look at what we're actually going to do there. Here we have a pretty simple main func. We have our workflow registry. Ignore the fact that this is like red. My IDE is just being weird rendering things right now. I just need to fix config. So it does all run and everything. It's just red for now. So yeah, we have our workflow registry. we're going to register order processing workflow, the main like Go workflow, and we'll look at the code for that as we get through this file. We're going to register those 2 local activities that we saw here. So if I come back here, it's the validate order, the first one, and then this last one, which is complete order. So validate order, complete order, local activities, perfect. Then we're going to create our workflow client. This is all the standard like boilerplate workflow code. So nothing new quite yet. We're going to start our worker. We have a health handler, and then we have our start workflow here. With that, we're going to just create a sample order. We'll calculate the total for these items, like a laptop and a mouse. And then we're going to schedule the workflow, the order processing workflow here. And then we're just going to wait for the completion. I have some log lines. We'll see some of those as I run it, but that's at a super high level. And then if we look at the order processing workflow code here, we'll see this logged, our workflow started. We'll get our input. We'll run the local activity to validate the order. This is still all the same code to call an activity locally. Then this is what is new with multi-app workflows. We're going to call this activity, the validate payment method activity on our payment service. And then we'll see this completed log. And then we're going to reserve our inventory, same thing. So call the activity on that other service. And then step 4, we're going to call the activity to generate the personalized recommendation on our AI recommendation service. And then we're going to complete the order, which is, again, that local activity. And then we'll see a log that our whole workflow completed successfully. And then I'm just going to gloss over these local activities, but this is the definition for those 2. We'll see some log lines about, it's starting and it completing. If I pop over to just show y'all quickly the Java code, we have a pretty simple main. We're going to start our server. All it's going to do is register the activity. So validate payment. And then obviously we have like a health handler and building and starting our workflow runtime. And here is that code for the activity on this application. And for all of the activities, I kind of say when it starts and when it completes. So we'll see those logs. So that's just one of the Java services. I do have the code for the other ones, but I'm just going to skip over showing that because we'll see it. Okay, so let's run all of those services with our Dapr run, passing in the multi-app config. We'll see the Go order orchestrator start. It registers the workflow and the 2 local activities. Then we're going to see the payment service start. It registers its 1 respective activity. Same for the inventory service. It registers its activity, and same for the AI service. It registers that 1 activity here. Then I mentioned I'm just going to call make test to start the workflow, and then we can see it completed successfully. And you can kind of see like the workflow started and processing the order, and we're going to call the different services, the payment processing, the inventory reservation, and the AI recommendation service. And ultimately all of those run and complete. And even you can see like the activity there at the end for completing the order. And then ultimately it does complete successfully. So it calls all the activities and whatnot. That is our demo. All the code's in the quick start repo. So if anyone wants to check that out, definitely do so. From here, some key takeaways. Obviously, we saw you can run workflows across multiple applications. You're no longer locked into one application. We have cross-language compatibility, where you can write it in various languages using the SDKs. I showed y'all Java and Go today. And then obviously with this, you get distributed workflow execution, where you can call activities in child workflows and other applications, giving you flexibility in your execution environment, whether you want like a GPU instance for ML training or secure processing for other applications. That sort of thing is enabled, where you still get centralized workflow history with the resiliency and durability guarantees from the Dapr workflow engine. And here are some docs and links if you want just a pure Java example, that's a link. And then more on the multi-app docs are there. Thank you.
Thanks so much, Cassie.
Thanks. Yeah, it's super cool because effectively you can now have sort of a workflow with a pool of activities or a set of activities that you can then share across other workflows. And that's one of the scenarios you can use this for. And that means that you can have shared activities, you can have particular activities running on particular pieces of infrastructure and hardware, and really kind of define a business logic that spans across multiple workflows now. Amazingly cool.
Yeah, thanks a ton. There are some questions still in the Q&A, so maybe you can have a look, Cassie, if you can answer some of those.
Yeah, definitely. Thank you.
Okay, thanks.
What's up next, Mark?
Up next is Mauricio to talk about workflows with Java Spring Boot.
All right.
Let me add Mauricio. Here we go. Hey, welcome, Mauricio.
Hello, folks. How are you doing? All good?
Definitely good.
Nice.
Yeah, looking forward to it as well.
All right. So let's talk a little bit about workflows with Java and Spring Boot. So building up on what Cassie was showing, I wanted to show a little bit about the Spring Boot experience on top of the workflow APIs when using Dapr. We have been doing a lot of work to make sure that we have like a Spring Boot like native experience. So using Dapr with Spring Boot applications should be frictionless. So in order to start using Dapr with Spring Boot, there are like two dependencies that you can add to your Spring Boot applications, to your existing applications. The first one is the Dapr Spring Boot starter, which basically brings all the helpers to just to start using the Dapr APIs inside the Spring Boot application. This will give you dependency injection and a lot of helpers just to bootstrap all the Dapr SDK and connections to a Dapr instance. Secondly, we have created an integration with test containers for the testing side of things. And this helps us to build a local development experience for creating your Spring Boot Dapr-enabled applications without the need of having a Kubernetes cluster with Dapr running. This will wire up everything that you need to work with your applications. On the workflow side of things, again, we try to make sure that for Spring developers, creating workflows is as just working with a normal Spring application. As you can see here, creating a workflow definition is super easy as you define the activities that you want to call or the events that you want to wait for. But in the case of Spring Boot integration, what we do is we make sure that all the implementations of workflows or the workflow definitions that you have in your applications and all the activity definitions that you have in your applications are Spring managed beans. And that basically means that they have access to all the other things that are available in your Spring Boot application context. I'm showing here, for example, like an activity inside the workflow execution. And by just managing this as a managed Spring bean, we can have access to all the other beans that are managed in the context. In this case, I'm injecting into my activity the customer store. So what I was showing before is kind of like a work definition. The only difference here in this slide about like normal Java and Spring Boot is this component annotation that makes the workflow part of the Spring Boot context. Similarly here with the activity. We just make the application, the workflow or the activity to understand all the other things that are happening in the Spring Boot context, so you can integrate with anything that you already have in your applications. Just to mention something related to multi-app execution that we saw before, the idea here is that if you want to transform an application that you already have to be kind of like one of the activities in one of the existing workflows, you can just define an activity and then just register it automatically in that application. So other applications that are running workflows can start calling that activity. And finally, like where the magic happens actually is using this new annotation that is provided by the Spring Boot integration that is called Enable Dapr Workflows. What this does is automatically scan the application class path looking for all the workflow and all the workflow activity implementations and automatically register that into the runtime for workflows, in this case, that lives inside the application. So whenever you want to start like a workflow, you have the Dapr workflow client automatically injected and configured to interact with the Dapr instance that you want to interact with. And then you just can use the APIs as usual, right? In this case, what we are doing here is we are saving you all the headache of setting up, the workflow runtime in your application, and it's automatically ready for you to work on. So before jumping into the demo, what I will be showing is this example. It's just an example for implementing compensations in workflows. And I wanted to show this because it actually shows the usage of Spring beans and in conjunction with like a workflow definition and some specific execution semantics that we want to build. So the scenario is pretty simple, and again, it's just for demonstration purposes. But what we will be looking into is a workflow that has these two steps that are basically interacting with an external system to perform a debit on a customer account. But the workflow is very specific. It wants to execute a debit on customer 1 and then execute a debit on customer 2. And if something fails in these two steps, we want to trigger some compensation, right? In this case, a compensation for a debit is usually a credit. But this compensation logic needs to be registered before running the activities themselves. The idea here is that if something goes wrong, we need to have a mechanism to actually understand what went wrong and then define when to execute these compensations activities. And now what I will be showing is pretty much kind of like that example in Java inside the Spring Boot application. We have this repository in Diagrid Labs that has a bunch of different workflow patterns that we are trying to refactor and to include that into the SDKs. But as I mentioned before, a workflow is just a workflow, implements the workflow interface. But because we are defining this as a Spring Boot component, now we can access all the Spring Boots, all the Spring beans that are available in the context. In this case, we have a helper bean here that basically does the compensations for us. And as you can see, we are just injecting this. So we are not defining how the service gets configured. We are just letting Spring do that for us. What we can see then in the workflow definition is that, as I mentioned before, we have two main activities that are create like debits by calling an external system. In this case, it's doing like an HTTP request to an external service. And we have one debit there. We have one debit here for the second customer. But what's important to show here is the compensation helper in this case. So the compensation helper here allows you to register like the compensation credit logic that needs to be executed if the debit request fails for some reason. And it's important to mention this because if you want to execute compensations, what you want to see is that you are storing kind of like the parameters that were sent to execute that debit. So you know exactly against which customer to execute the compensation. So what I will do next is I will just basically start this Spring Boot application locally. This Spring Boot application is configured to use the Dapr test containers integration to start Dapr right besides the application, right? So I'm starting my application and Dapr is being started as well as part of this. And as soon as like this finished starting, we can actually send a request against the application. Yeah, so that's Dapr starting, that's the application starting. And I'm starting again a mock server because I'm calling some REST endpoints. So what I can do now is I can send a request to this application. And what's going to happen is that a new workflow will be executed, a new instance is created. So I get that instance ID. We can check that out later. But inside the output of the application, we will see that, like a new workflow instance was created, a new debit was sent to the external service, and everything worked well for this customer that it's called other. But then when I'm trying to execute the second debit payment for this customer, Salavo in this case, I'm getting kind of like an exception from the workflow, right? Like something is failing when I'm trying to execute the second debit. And that's where the compensation basically start working on. So the compensation said, the last thing that I executed was debit 2. Did that fail? Yes, that failed. But I didn't manage to call the external system, so I don't need to actually execute a credit for that transaction. But the first transaction was successful, so I definitely need to execute a credit on that customer because I managed to create a debit for that customer. So again, this shows like a very simple example of a workflow with compensation that you can execute. And as you can see here, looking at the logs, like the execution of the workflow happened correctly. But I wanted to show you quickly in the last minute is how can you run this against, Catalyst, which is Diagrid's managed Dapr server. So what we're going to do in order to execute this against a remote environment, which I think it's also part of the Spring Boot integration, is we are going to change the properties here, the property files of my Spring Boot application, which basically allows me to say, do you want to start Dapr locally or not? I will basically not start Dapr locally now. That basically means that I don't have a Dapr instance running in my machine. And in Spring, you can actually set these three properties to connect to a remote instance of Dapr running somewhere else. In this case, I will configure that to run against Catalyst. You can do that by setting these properties, which are Spring Boot application properties, or you can set that using environment variables, which is what I will do now, which is a little bit closer to what you will do like if you're running in Kubernetes, right? So no matter if you're running locally or in Kubernetes, you can actually interact with this remote service. And what I will do now is the same as again, I will just start the application. But in this case, Dapr is not going to start locally. It's going to start remotely. It's going to just connect to Catalyst that is running the Dapr APIs. So let's wait for the application to start. In this case, again, it's starting the mock servers because I still want to use the mock servers. And what we can see here is that the application started. The application started correctly. Now I can start a new instance of the workflow and just see if this works in the same way. And as you can see, yep, so I started the new instance. Now I have a workflow ID. We can see that the output is actually, believe me, the output is exactly the same. But what I wanted to show you now is the Catalyst UI. What we can do here is we can just get the ID that we just executed. So we can go and look into the workflow execution for that specific instance. And as we can see here in this diagram, what we see is that we executed the first activity and the payment was processed successfully by the external system. The second debit was not successful, so we got an exception from this activity that was calling the remote service. But then we trigger compensation. So we have two executions of the compensation activity, one that basically checks that the payment wasn't processed, so I don't need to actually put a credit into that customer account. But the second one is processed correctly and then just send the credit to the customer account. Again, in Catalyst, you can actually see all the inputs and outputs for all the activities that were executed by the workflow engine, and also the history of all the events that were executed as part of that execution that can give you more insights about what's going on with your workflow executions overall. You can also filter by type and by state of the workflow, so you can see that this workflow is completed. But if you can imagine that you're running thousands of these in parallel, you wanted to actually see them grouped, so you can see them by type or by state, or by the final state. Like if something failed, you can actually quickly go to the failing instances and see what's wrong and try to retry the execution. I wanted to finish the presentation by sharing with you a little bit of what's going on with the Spring Boot integration. We have a very interesting roadmap coming, trying to simplify this experience for Spring Boot developers, but also integrating with some other tools. Like as I mentioned before, we integrated with test containers for the local development experience. We have some examples with microx for mocking and just testing these workflows with mocking services, or just making sure that we're calling the right services when we need to call them from the workflow code. And finally, as you saw, by just setting 3 different environment variables, you can configure the entire application to connect to a remote instance of Dapr, like Diagrid Catalyst, that it's a managed service running the Dapr interfaces. Finally, I wanted to share kind of like these 3 links, like the Spring Boot documentation in the Java SDK, the workflow patterns that are hosted nowadays in the Diagrid Lab repository that shows a bunch of different workflow patterns that you can execute and build with this workflow engine. And something that I will be publishing a blog post in the following week, it's about Spring AI and Dapr workflows, which is a very interesting use case on how we can create agentic patterns using workflows, and how this brings kind of like durability to the execution of multiple LLM calls, or these more advanced agents that are just controlling which tools are being called at what time. So keep an eye on that if you're interested in that space, because there will be a couple of blog posts coming in the next couple of weeks. And I think that's all I had from my side, Mark.
Fantastic stuff. It's amazing, that combination of workflow and Java Spring Boot and putting them together. It works really nicely.
Yep, it's super good.
Yeah, thanks a lot, Mauricio. Great to see. And of course, it's very nice to see this workflow visualizer in Catalyst, right? I think it's the first time that we're showing this. So that's really cool.
The conversation was pretty cool, actually, the way it failed, and you can see the recovery around this all inside the code.
Mhm.
Great stuff. And you posted your links to the Java samples inside the chat, yes?
Yes, I will share that. Yeah.
Okay.
Cool. All right. Just as a quick shout out for Dapr University. So if you're interested to learn more about Dapr and also Dapr workflow, we have like a Dapr workflow track on Dapr University. So if you go to diagrid.io/Dapr-University, there are like 3 lessons now. This is the second one. So if you want to learn more about Dapr workflow, you can access this content in .NET, in Java, and in Python. It runs completely in a cloud environment, so you don't need to install anything. So this is like an hour's worth. You go to all of the workflow APIs, all of the patterns like task chaining, fan out, fan in, monitor. So you can really play around yourself with Dapr workflow.
Pretty cool.
All right. I think it's time for our next speaker to talk about the conversation API and Dapr agents. So welcome, Bilgen.
Thanks, Mark. Great to be here. I'll share my screen and get going. So my name is Bilge Ibrahim, product manager at Dapr, working on the AI, all things AI, and I'll share you what's happening with Dapr in that space. Here I have a quick overview of a typical path of AI adoption. So for example, you may start interacting with a single LLM. LLMs are really good in chat completion, like text summarization, text generation, or formatting text, right? But interacting with LLM for this purpose, you may quickly realize that they are stateless. So you need to provide memory so you can keep a history of the interactions and other preferences. LLMs have knowledge cutoff, so they don't know anything beyond their training point. They don't know anything about your private data, so you end up giving augmenting LLMs with tools so that they can access the external world or even modify that world, write data, right? And further in this journey, you may realize that LLMs are actually really good, not only in chatting, back and forth, but actually running in the background in a headless mode, like an ambient agent, right? Where they can be part of a long-running process that interact with the user for approval, etc. They can call tools until a task is accomplished. And I would say this journey kind of very well represents also the different areas we are working in Dapr. For example, Dapr Conversation API is really good in simple LLM interactions, but the moment you want something more, executing tools, memory, this way you would use Dapr agents. And in Dapr agents, we have 2 flavors, just a simple agent and the durable agent. And the durable agent is the headless ambient version of that can run in the background in a reliable way. So I'll try to give you a quick demo of all this and tell you what's happening. So Conversation API, aligned with other APIs, really the goal is to give you a consistent API to talk to other LLM providers. It is very much inspired and following the OpenAI's chat completion API and gives you abstraction on top of the other LLMs. Similar to the other APIs, that gives you ability to provide resiliency policies, see the tracing metrics, apply Dapr security features to get tokens, to scope infrastructure components, and so forth. In addition, it can do caching a few prompts and obfuscate of the data. In 1.16, there were a few new components added. So now you can also talk to Olama based models and Google AI models. In addition, we've also opened up and extended the OpenAI component. So now you can specify a different endpoint and talk to OpenAI models hosted not only by OpenAI, but other places like Azure or Qwen, etc. So you can talk to all of this. In addition to components, actually the main improvement has been adding a tool calling support. Tool calling is a common pattern in chat completion, where you give a list of the tools to the LLM, and the LLM can tell you which tools to execute with which parameters. Once you've done that, the LLM can accomplish its task. The way to pass that today is you need to give a JSON schema of the tool definitions, and the different SDKs in Dapr have different utilities. For example, the Python SDK, I believe it can generate this kind of schema from your function definitions. This tool calling support is based or following the OpenAI's tool calling format. So you have only one format to do tool calling from Dapr point of view. Behind the scene, Dapr will adapt the different LLM, different providers tool calling, so you don't have to worry about any of these differences. Since this is a new capability API in the API has moved to Alpha 2. So if you want to use this, you have to basically update the version of the conversation API. Now, to use tool calling, in reality, you need something like an agent, because the moment you pass the tool calling information to the LLM and you get back, you have to execute the call, pass the information. So it's a loop that can run multiple times. And the best way, I would say, to use the tool calling with conversation API is using Dapr agents. So let's see a quick example of that. Basically, I want to show you how you can use conversation API and a simple agent in Dapr workflow. So here I have a workflow. It is a very simple workflow that does task chaining. There are two activities. The first activity is get character, and the other one is get a line from that character. So if you look into the get character activity, you see how you can use the conversation API using the Dapr chat client. Converse Alpha 2 is the name of the API. Here I'm specifying the component I want to use. I'm using here a OpenAI mini component, so I want it to be, cheap, and I'm giving it a full creativity with temperature 1 and so forth. And in the middle, you can see how I passed the request. That's the first activity. And if I go to the second activity, this one is a get a line. And here I'm actually running an agent because I want to perform tool calling. And if I look into the agent definition, this is basically a stateless, non-durable agent from Dapr agents. It has name, role, goal, a prompt. I'm giving it a tool, a function, which validates whether the character is valid or blacklisted. In this case, it says that they're all valid, basically. And here I'm using Dapr chat client. This by specifying Dapr chat client, I'm making sure that this will use Dapr conversation API when talking to the LLMs. And the actual component that's used with all the details, how to talk to OpenAI, are in the component definition as per all Dapr components. In addition, I can also specify to use a memory for this agent, so it will keep track of all the interactions. So if I run this workflow, we should see an execution first of a simple conversation API call, and after that, an agent with tools, again, using conversation API behind the scene. So as you can see, first it got a character using conversation API Gandalf, then getting a famous line, but the system said, no, this is not a good character, and we didn't get the line. If you run that a few times, we would get a line. So this is the first demo. Going forward, in the Dapr agent space, in the last couple of months, we've actually done tons of improvements. Specifically, we simplified the different agent types. Now there are only two: durable agent, which you will see in a moment, which is backed by workflow, and agent that you saw in action. Both of these can use conversation API, so they can use Dapr for memory, for talking to LLM, for execution. We've added MCP support, so you can actually interact with all the different MCP servers using server-side events, streamable HTTP locally with STD.io, and use those MCP tools as agentic tools. There is integration with OpenTelemetry and Zipkin for tracing, with Open Inference Spec for more advanced observability, so you can actually see the prompts, the responses from the LLM, etc. And all of this documentation is actually now merged into Dapr documentation. Let's see a durable agent in action. So, as mentioned earlier, durable agent is very similar to the other agent we've seen. It has, a name, goal, a prompt, what to do, a tool again. But in addition to a stateless agent, now I also have a place to store the actual execution, which behind the scene is backed by Dapr workflows. So this agent, when it gets a prompt, it will create a workflow on the fly, and each interaction with the LLM, with the tool execution will be durable. They will be individual activities. This is where the workflow execution will be stored. Here again, I'm using a separate store just for the chat history if I want to pass that to other executions. In addition, there is also a way to register this agent in a registry and interact with it over PubSub. Finally, I'm going to start this agent on 8001 because I want to interact with it not inline, but through REST call. So if I go to, hide this, O2, durable agent, headless, and I execute this agent. Now we should see that it starts on the REST endpoint on 8001, which, if everything works fine, I should be able to hit it with a REST call. So here I'm saying it's an agent that starts workflow endpoint. I can tell it, for example, find me flights to the top 5 capitals of the world, right? And hopefully, if this has started, see, we got back a workflow ID, and we can see now this is running. Now I'll just hit Control-C and I will stop the app. Let's see what happened. This is my prompt. I want to find flights to 5 capitals. The LLM came back with saying, perform these 5 tool calls, right, to each of these capitals. And I think so far only one of the tool calls executed. We can see the price of this one and none of the others. And the reason for that is, if I look quickly at the call, that these tool calls actually randomly, half of them do take 20 seconds and the other half will be executed instantly, right? So if I now bring back this agent, it should continue the tool execution where it left off. You see it actually picking up the tool calls for the other 3 capitals. In total, they should be all 5, and the workflow should finish successfully. A good way to see that is actually the a JSON file which is created where you are running the agents. So here, if I see this execution, this file should update while the agent is running. We can see all the executions, tool calls, and if I go towards the end, it still says it's running. Okay, I think I got back 5 results. So this is the response from the LLM. I have found flights for 5 capitals of the world. So this shows you that the agent execution is, durable, persisted on the disk, and the workflow is created on the fly based on the LLM decision. So it's a great way to have workflows that are non-deterministic. You don't code the actual execution as in the first example, but they happen on the fly. Specifically on durable agents, what's been happening is we are really focused on making these durable, reliable, so backed by Dapr workflows. That's the main focus. Some of the things that are coming here is we want to clean up more the way you define the durable agent, so cleaning up the DSL, make the interaction also resilient, so they're by default sufficient retries, for example, ability to interact with other agents as tools, and human in the loop. Basically, an ability for the agent to stop at certain tool calls and wait for an external event, typically human approval. Now, while this is going, I'll just hit quickly. I'll just try to run this against Catalyst. So we also have an example of how this looks in real time. So now I'm running the agent towards a Catalyst rather than a local Dapr instance. This will run against Catalyst. It will provision, all of these components I'm using, and hopefully this can be a bit time consuming, but it should start shortly so we can see the workflow on the fly. Let me see how it goes. If it's taking too much time, we'll skip this part. Okay, so this started the workflow. So if I go into Catalyst where we have the workflow visualizer, you can see the new workflow instance. It's an agentic workflow, so there is no existing definition. Here is my input to the workflow, and we can see live what is happening. It basically calling the LLM with the prompt. LLM is responding back with specific tool calls that the agent now should shortly execute. You can see them live. Actually, all 5 tools calls are happening in 5 activities in parallel. Some of these should finish instantly, and some of those should take 20 seconds. But the agent should wait for the completion of all of them before sending them to the response. The good thing here is, again, I can see exactly what activities are happening and the input and output of each of these. I think all tool calls finished. Surprisingly, they all took 25-ish seconds. At the end, then we called back to the LLM with the result of the tool call, which took 7 seconds, and the final result. So now if I go at the top, I'll see the output and the flight details. So that's a nice way to see, a workflow created on the fly without hard coding in a programming language. So the takeaways here is you can use conversation API, simple agents within existing Dapr workflow if you want a deterministic flow. And if you want an agentic workflow and you can prompt the LLM to create the right workflow for you, you can just use durable agents. We have great state of quick starts and documentation. So have a look into those. And lastly, we also have a Dapr University where you can go and run these quick starts in a guided environment and learn about Dapr agents.
Excellent. Thank you so much, Bilgin. Yeah, perfect. Yeah, this is also I want to show as well. Yeah, so if you're interested in trying this yourself without the need of installing anything locally, just go to Dapr University and just run this course. You only need like an OpenAI API key, so that's what you need for yourself. But other than that, you can just run this course for free. Right.
Yeah, amazing visualizations there of the live running workflows doing all the tool calling as a catalyst and seeing how they operate. It's
cool stuff.
You can see the real interaction of how an agent actually works, as well as the durability, the recoverability of that.
All right. Thanks, Bilgin.
Thanks, Bilgin.
Thanks.
All right. Then I'll announce our final speaker, and that is Joni, and he will talk about federated identity. So let me add him to the stage. Hello, Joni.
Hello. All right, to take over the screen sharing.
I will stop this. Go ahead.
With me. Okay. All right, perfect. So yeah, my name's Johnny Collins. I'm an engineer at Digrid. I'm going to be talking through some of the improvements we've made around federated identity in Dapr 116. So the first thing I'm going to talk about is why you might be interested in using federated identity. And I guess the two kind of headlines for this are, one, it's a much more secure way of handling component authentication in Dapr, and we'll dig into why that is. And also it's built on top of an open identity standard called SPIFFE. And what that gives you is a stable and portable identity, so it's not vendor specific. And it's also interoperable with lots of service providers and sort of travels with your application no matter where it's running. So as you probably all know, Dapr provides APIs to your application that abstract the underlying infrastructure, typically from some form of service provider. And they do that through a component model. So you define a component that is a configuration for how Dapr should talk to various different types of infrastructure. But you need in that process to tell it how to authenticate. Obviously, most service providers are going to require some form of authentication. And the traditional way of doing this, which is a great way that's been around for a very long time, is to use a secret reference inside your component. So that means that you don't have to code a secret value inside your component. You can just reference a pre-existing secret that lives somewhere, and Dapr will only resolve that at runtime to keep it secure, so it's not going to get leaked anywhere. However, this still does mean that you need to manage the secret yourself, right? So you need to provision that secret and put it wherever you need it to be. You need to rotate it if that's what you're going to do, and you also need to think about how you revoke it if it is unfortunately leaked. But what this allows you to do is that Dapr will resolve that. It will use the secret to authenticate to the service provider to access the infrastructure. And because the service provider has a hash of that secret or whatever, it'll be able to verify it and say, cool, you can access this infrastructure. But what we're looking at is there's a better way to do this based on identity. So first of all, in Dapr, what is an identity? So fundamentally, an identity is literally just a string that encapsulates attributes and claims about an application. So in Dapr, it has this form, and as I said before, we're using Spiffy. So Spiffy kind of gives us the framework and the structure of how this string should look, so that it can be interoperated with, is that a word? Interoperable with other tooling. So you'll notice that this is application specific, right? So it's not infrastructure specific. We're talking about namespacing, so we can isolate applications. And then we have the application ID, which is effectively the application name at the end. So this is great. The identity says this is who I am. But how does the service provider actually trust that is authentic? Because it doesn't know anything about it, right? And this is where federation comes in. So what we're working on in Dapr is being able to allow service providers to federate trust to Dapr itself. So Dapr Sentry is a component in Dapr that issues the identities to all of the Dapr runtimes and control plane components. So it's the one that's signing credentials and giving those out to all of these components of Dapr. But when that component, those credentials are provided to the service provider, it needs to know how to verify them. So Dapr Sentry issues X509 certificates, and it has done that for a very long time. But with Dapr 116, we're introducing JWT issuing. So you can opt into this in Dapr 116. It won't do it by default, so you need to configure it on the Sentry installation. But if you do opt into it, all sidecars will receive a X509 certificate and a JWT from Sentry. And then you'll be able to set up federated trust from the service provider to Sentry so that we can trust those credentials. And we'll look in the next slide how this works. But ultimately, your application will be able to speak to Dapr, and Dapr will be able to manage the underlying secrets on your behalf, right? So you won't really see the secrets. This will all be done transparently to you, and everything will be rotated under the hood by the service provider in Dapr, and you'll just be given access to the underlying infrastructure. So just quickly, how this might look in Azure. So Azure has this concept of a federated credential, and this allows you to basically federate trust for access to a service account in Azure to an external OIDC provider. So as of Dapr 116, you can actually configure Dapr to both issue JWTs, but also expose an OIDC discovery endpoint. So if you expose that to Azure, so that Azure can call the OIDC discovery endpoint, it'll actually be able to set up federated trust, right? Which means that you can use the JWT with inside Dapr with Azure components to authenticate to Azure, even if you're not running in Azure. So this is a big difference to call out between something like a managed identity that you might be familiar with, and that works by if you're running in you're running in Azure. Your workload will actually be able to get a credential from the hosted infrastructure itself, and then use that to access Azure. What we're doing here is we're trusting the actual native Dapr identity. So this is a stable string that represents your application that is signed by Dapr, not signed by the Azure infrastructure, but Azure is federating trust to allow you to do that. And then what happens under the hood is there's a credential exchange between Dapr and Azure, and then the underlying credential that will be given by Azure will allow your application access to the infrastructure. So as a database or a storage account or whatever, Azure will just do the authentication based on your app identity in Dapr. So this is also possible in AWS, and actually this is possible pre-Dapr 116. This is actually possible in older versions of Dapr. AWS has a service called IAM Roles Anywhere, and that actually supports X509 certificate authentication and authorization. So that means that you can actually use the X509 certificate to talk to AWS IAM Roles Anywhere, have it exchanged for a token to access the underlying infrastructure. What you need to do in the case of using X509 is you need to distribute the trust bundle, that is the public part of the sort of CA for Sentry, to somewhere that AWS can access it. So you set up some trust anchors and a trust relationship in AWS, and then it will verify those credentials and allow your Dapr sidecar access to the underlying infrastructure. And what you'll notice here is that the SPIFFE ID is exactly the same for AWS as it is for Azure, as it will be for any other infrastructure that you're accessing. It is your application identity. It's the same string that will be used for access control policies for internal Dapr to Dapr calls as well. So it really is a universal identity that can be used to interact with any services or applications. So I just wanted to quickly wrap that up with a few highlights. So federated identities are a really good way to mitigate the need for secrets, because you are no longer responsible for the secrets. You just need to set up the trust relationship, and Dapr will take care of the rest. It's also a stable identity from Dapr and not the infrastructure. So you're not relying on Azure's identities. You're not relying on AWS's identities. They're federating trust to Dapr, and it is your Dapr identity that we are trusting here. Dapr 116 now adds support for JWT issuing and OIDC discovery endpoints, so this is great for Azure. So both AWS and Azure can federate to Dapr today, but we've laid the plumbing and the groundwork for this to work across lots of different providers. So if you are interested in having identity federation in different components, so say GCP or any other provider, do raise an issue on the components contrib or Dapr runtime. We can move it, and we'll be able to add support fairly easily. There's a couple of links here. I did recently write a blog that goes into a bit more detail on this called Universal Application Identity with Dapr, so please check that out. And there's also some information on how to set this up with AWS and Azure as well. All right, thank you, Mark.
Great stuff, Joni.
Awesome.
And definitely need people read this blog post. Yeah, it's really a super high quality blog post, so definitely check that.
Thank you very much.
All right. We're almost at the Lego part, don't worry. But before that, I want to quickly share how we can actually upgrade to 116. I'll mention like two versions, right? Either you run everything locally, so you need to upgrade or at least download the latest Dapr CLI. Of course, you need to uninstall the 115, or maybe you're even running an older version. Then do like a Dapr init to actually reinstall the latest version, and everything is like pretty well described in the Dapr docs, right? So where and how to download and install Dapr CLI, and also how to install Dapr in self-hosted mode, because that's what we call it when you're running Dapr locally. Now, if you're running on Kubernetes, there are like multiple options. You can still use the Dapr CLI. There's also a Dapr Helm thread you can use. But yeah, the easiest way to upgrade Dapr is probably using Dapr Conductor, which is like an operational tool to manage your Dapr control plane. So let me quickly show you how it looks like. Let me move to another tab. So this is Conductor. I have one cluster, which is just my local development cluster. It's a kind cluster in this case, just running a couple of applications. And in this overview, you can already see that this is running on Dapr 1.15.11, and there's like an arrow pointing up here. That means there is a Dapr upgrade available. So let me zoom into this cluster details, where there's a summary about the health of my Dapr control plane here. And here in big numbers is the Dapr version 1.15.11. And this is actually a button that mentions 1.16.0. So this you can click. And well, the latest version is already pre-selected, but you can also see all of the other versions that you can download and install. You can also either choose to roll out all your applications with the new sidecar as well. Just hit the confirm button, and then it will install and upgrade Dapr control plane to the latest version. And in case something goes wrong, it's actually roll back to like a healthy state. So yeah, this is probably the easiest way to upgrade to Dapr for your clusters.
Yeah, and upgrades all your applications as well to sidecars at the same time,
Exactly.
which is a consistent upgrade across the two, which is the amazing benefit of what you can do inside Conductor. So you can sign up for Conductor.
Yes, exactly. Yeah, go to digrid.io/conductor to try that out. Useful for both local stuff, but definitely, of course, also for running in production, right, for your Kubernetes clusters. All right. Again, I want to mention Dapr Day. So if you haven't registered for this, it's a free event. We will have lots of people talking about running Dapr in production, client cases there. So definitely sign up. Also, if you want to share your story or your local development story, please submit for the call for papers, which is open until the last day of this month. Yeah. Right. Well, thanks everyone for staying this long. I think the sessions were really good. So thanks to all the speakers as well. And see you again next time, either at the Dapr community call or one of our Digrid webinars where we go run through the Dapr University stuff as well. So just lots of Dapr content.
We have a community call next week coming up. Yes. So
exactly.
Join us at that, where we'll be highlighting even more things that are happening inside the agentic space and inside Dapr 116. And thank you everyone for joining today, and thank you for all the speakers. As you can see, 116's got an amazing amount of content in here. We covered both the highlights. If you want to find out more, go to the Dapr Discord channel there and spend some time and ask questions.
Yeah.
Thank you.
Thanks, everyone. See you next time.